Hey Algebra 1, sorry about the video. I did mean to flip at all this chapter, but I didn't feel good, so you're going to need to take notes in your notebook, and this will be the first section that we start off with after EOC. It's still going to be in chapter 9, and then we're still talking about quadratics. We'll be solving quadratics in different ways. We already know how to solve by factoring, and so we're going to show you a couple more ways how you can solve quadratics. The first way is by isolating x, and you've actually seen this before. You just didn't know about it. So for example, with the Pythagorean theorem, if I asked you to find the hypotenuse of a right triangle with legs 4 inches and 3 inches. So if we had a right triangle and we knew the legs were 4 and 3, how can we find the hypotenuse? Well, we're going to set up the Pythagorean theorem and do 4 squared plus 3 squared equals c squared. And that's 16 plus 9. And we keep following with the process, we get 25. Now right here at the very end, we are going to isolate c. And the way we do that is by taking the square root of 25. And we know that c equals 5. And if 25 wasn't a perfect square, we could use our calculator to figure out what the square root is. So you might need your calculator for some of these problems. But I will tell you, even though you've seen this before, there's also another answer to this equation. I kept telling you whenever we were doing factoring that if you saw like an x squared, that you had 2 answers. When we use the Pythagorean theorem, it seems like you only get 1 answer. Well, I'll tell you, the other answer comes from the fact that negative 5 squared is also 25. So if I take negative 5 and times it by itself, I get positive 25. So there's actually 2 answers to this problem. The issue is negative 5 wouldn't make sense for the length of a hypotenuse, so we ignore the negative in these situations. We do that a lot in geometry. And so our answer is only 5. But again, technically there were 2 answers to that equation. So you've seen isolation before. Another place we can use it is with vertical motion. And before we used our calculators just to figure out what the answer was, but here's a way you can use isolation. You can only use it with the dropped situation, and so there's no velocity. So here's a dropped object. You dropped it from a height of 100 feet, and the question is, when will it reach the ground? And so again, the ground has height 0. We have negative 16 t squared plus 100. And we're going to go ahead and isolate. And if I write too fast for you, just feel free to pause the video so you can catch up. But if we're going to solve for t, first thing I would do is my adding and subtracting. So I'll get rid of that 100 and bring it to the other side. The second step in isolating, just like I would a normal equation, I would divide by 16. Now, what I can do is I can take that fraction, 2 negatives make a positive. I can reduce it, 4 goes into both of those, 25 over 4 equals t squared. Notice the 16's canceled. Here I am again, just like I was with Pythagorean theorem. At the very end, I'll take the square root, and the square root of 25 over 4, you could use your calculator, or with a fraction, we could just take the square root of the top, and that would be 5, and the square root of the bottom, which is 2. Now again, technically there are 2 answers. The other one would be negative 5 over 2, but it doesn't make sense to have negative time in this situation. 5 over 2 is also 2.5, so you could write your answer like that as well. So 2.5 seconds. So that one we didn't need a calculator, but of course you could use it if you wanted to. Now let's just do some regular problems. So we're going to solve these by isolating x. Again, if you want to pause the video so you can write down the examples first, that's fine. So for example number 1, to isolate the x, I see there's this 2 in front. We need to divide out the 2. And I get x squared equals 72 divided by 2 is 36. On a normal equation, on a linear equation, I'd be finished. But here at the very end, I need to do the square root. X equals 6, because 6 squared is 36. But remember, there's an x squared. There should be two answers. The other answer is -6. When I take -6 and I square it, I also get 36. The tricky thing about these problems, there's nothing in this problem that's going to remind you to put that negative other than the fact that you should know if there's an x squared, there's two answers. So we have to be aware of the type of problem we're solving. If you look at number 2, I see there's a -10. We always get rid of our plus and minuses first. So then it says 3x squared equals 10, and we'll divide it by 3. So x squared equals 10 over 3, and I'll do the square root. Now before, when we did the fraction, we had perfect squares, but 10 is not a perfect square and neither is 3. So I'm going to go ahead and plug that into my calculator and get an approximation. It is about 1.825. And let's remember, again, nothing is going to tell you this other than to be aware of the problem. Also negative 1.825. By the way, another way you could write these answers, besides writing both of the numbers, we could just use the plus and minus symbol. Plus and minus 1.825. Like the one above, we could do plus and minus 6. That's really it. There's just one more example I wanted to show you. Something else that could happen. On this third example, if you subtract 12, you get -10. Ask yourself, what times itself gives us a -10? What times itself gives you a negative number at all? There is no such number. There's no number we could possibly plug in for x. Even if you tried to do this in your calculator, you should get an error because there are no square roots of negative numbers, no real square roots anyway. And so what we would say to this is there is no solution to this problem. This will happen anytime you get a square root of a negative number. Or if it says x squared equals a negative, you will have no solution. And that's the end of the video. And the sub will give you your assignment. It's also on Google Calendar. Have a good day.